It's strange how easily we grow certain about the universe. We build our models, draw our diagrams, feed equations into machines, and convince ourselves that the sky behaves the way we've described it. Every orbit has its rhythm, every comet its reason. And yet once in a while, the universe shifts just slightly, and all those lines of certainty begin to tremble. It happened again on a cold night in early November. Astronomers in several observatories, from Chile to Hawaii, recorded something that made even the most cautious among them sit still and stare. A familiar name appeared in the data. Comet 3OI Atlas, an old traveller, one that had already bent a few rules of orbital mechanics in previous years. But this time it was doing something no comet was supposed to do. The images arrived in fragments, streaks of light, faint, then sharpened by software and patience. When they were finally aligned, the picture showed a sight that left experts speechless. Atlas was firing jets of material into space-massive luminous streams extending millions of kilometers in both directions. One pointed toward the sun, the other away from it, as though the comet were pushing and pulling at the same time, defying the very wind that should have carried its dust outward. At first, no one believed it. Astronomers are cautious people by necessity. They trust instruments, not astonishment. The first whispers were about calibration errors, overexposure, digital artifacts. Someone joked that it must have been an echo from the telescope's own optics. But data from independent observatories came in within hours, and every line matched. The phenomenon was real. What the images revealed didn't fit into any known category. In the language of comets, direction is destiny. Radiation from the sun pushes everything, gas, dust, frozen fragments, outward. Every comet's tail points away from the light. It's a law of motion so old and dependable that we teach it to children. But Atlas seemed to have forgotten that rule. It was ejecting matter directly into the path of the solar wind, and doing so with enough force to hold its shape across 1 million kilometers. The second jet was even longer. It reached 3 million kilometers in the opposite direction, farther than the distance from Earth to the Moon. And both streams glowed faintly blue, like breath caught in starlight. The reaction across the scientific community was a mixture of wonder and disbelief. You could hear it in the tone of their public statements. Calm, measured words wrapped around a trembling core of fascination. One observer wrote, "The object exhibits bidirectional jet activity inconsistent with conventional cometary models." Another called it a structure of unexplainable symmetry. Behind those phrases lay a single shared thought. This shouldn't exist. People like to imagine that science greets every anomaly with excitement. It doesn't. In truth, the first instinct is always to protect the model to bend reality, just enough to make it fit. Maybe the jets were optical illusions. Maybe they were caused by the comet's rotation. Maybe dust reflections created the illusion of symmetry. Each theory was tested and discarded in turn, and then came the numbers. When measurements from spectrographs and Doppler readings were compiled, the energy required to produce those jets turned out to be enormous, far beyond what sublimating ice or surface gas could deliver. If the data were correct, Atlas was releasing more mass each month than its entire body could possibly contain. That was when Avi Loeb stepped in. Loeb, known for his unshakable calm and unwillingness to bow to consensus, ran the figures himself. According to his calculations, Atlas was losing roughly 50 billion tons of material every month, while the comet itself weighed only about 33 billion tons. The math was impossible. You can't lose more than you have and still exist. For a moment, science was forced into silence. The paradox couldn't be brushed aside as a measurement error. Too many instruments confirmed it independently. Yet if it was true, it meant one of two things. Either our understanding of cometary physics was wrong, or something was happening inside Atlas that we didn't and perhaps couldn't yet explain. The first option was humbling, the second was terrifying. When the findings became public, most observatories softened the language. They described mass loss discrepancies and unknown energetic processes. But in private, many admitted the same uneasy thought. Atlas was behaving as if powered by a mechanism, not a meltdown. The media, of course, turned it into noise. Headlines spoke of mystery jets and alien engines. Scientists rolled their eyes. But quietly, beneath the surface of all that skepticism, something stirred a collective realization that this event wasn't going to fade into the usual cycle of discovery and dismissal. It was too strange, too measured, too deliberate. And so, for the first time in years, humanity's instruments, radio, optical, infrared, were all pointed at the same target, waiting for a clue that could make sense of it all. As weeks passed, more details emerged. The jets weren't chaotic. They didn't flare and vanish as normal outgassing does. They remained steady, pulsing at intervals that almost resembled rhythm. That word made everyone uncomfortable. Comets don't keep time. But Atlas did. Its light curve showed periodic rises and falls, each lasting roughly 11 hours. The timing was exact, repeating with machine-like consistency. It could have been rotation, yes, but rotation that perfect hinted at structure, stability, and balance far beyond what loose rubble and ice could sustain. And then came the colour. Comets are usually white, grey, or slightly greenish from carbon emissions. Atlas began to shift. First faint blue, then electric azure, radiating in wavelengths shorter than sunlight itself. That kind of glow doesn't come from reflected light. It comes from energy. No telescope could find the source. The jets carried no detectable gas lines, no dust. The coma around the nucleus, the halo of vapour every active comet wears like a crown, was missing. Atlas shone as though the light came from within. Somewhere, between math and meaning, the familiar story of comets fell apart. And yet, as unbelievable as it seemed, no one could stop watching. The question wasn't just what Atlas was, it was what it implied. If one object could defy every known pattern, how many others had passed unnoticed, dismissed because they didn't fit our comfort zones? Science, after all, is built on repetition. But progress often begins with the one thing that refuses to repeat. So they kept observing. Night after night, data streamed in. Brightness, velocity, heat signatures. And as Atlas moved deeper into the solar wind, it did something even stranger. It began to slow. Not because of drag or mass loss, but because the direction of its acceleration shifted, as if responding to forces we couldn't detect. It was acting like a vessel adjusting its course. No one dared to write those words publicly. But among quiet channels of correspondence between research teams, the tone was unmistakable. This object wasn't following the rules of nature. It was following instructions. In the weeks that followed, Atlas became the center of a quiet storm. Every major observatory turned its attention toward it, each one trying to find a crack in the mystery. The data kept coming, clean and relentless, but instead of clarity, it brought contradictions. Some telescopes recorded faint variations in brightness along the jets, tiny flickers that repeated in symmetrical waves. Others caught hints of secondary trails branching from the main streams, as though smaller fragments were peeling away from the core and releasing their own light. It looked like the slow motion of something breaking apart, but even that didn't behave the way it should. If Atlas were fragmenting, its light should have pulsed irregularly, chaotic and unstable. Instead, the pulses were disciplined, almost orchestrated. Each surge of brightness was followed by calm, as if some invisible pattern governed the sequence. Scientists began using new language to describe what they saw. Not eruption, but event. Not disintegration, but release. Words that suggested control without admitting it outright. Thermal models tried to explain it with physics. The side facing the sun reached hundreds of degrees, while the opposite hemisphere remained frozen near absolute zero. Stress built up between the layers of ice and rock until fractures spidered through the crust. Gases trapped below burst outward, propelling dust and vapor into the void. It was a familiar process, except for its scale and direction. The jets were too aligned, too constant, and far too powerful for random surface ruptures. One simulation showed that the pressure required to drive a jet against the solar wind would exceed the tensile strength of solid ice by a factor of 10. Another calculated that if Atlas truly expelled 50 billion tons of material a month, the nucleus should have collapsed within days. Yet the comet held its form, glowing with eerie stability. At a closed symposium in Geneva, a veteran astrophysicist summed it up quietly. It's as if the object understands how to survive itself. No one replied. There was nothing to add. The conversation soon shifted from what Atlas was doing to why it was still here. Comets are fragile. They die young, burned, or torn apart by the forces that shape them. But Atlas moved with the poise of something built to endure. Its surface reflected light as if smoothed by design, not erosion. Radar readings suggested density far higher than ice, and dust should allow closer to stone or metal than to frozen water. That raised uncomfortable possibilities. Metallic comets exist, yes, but they are small, heavy, and dull. Atlas was vast and radiant. If its surface was metal, then what was fueling its jets? If not metal, how did it withstand the temperatures that should have vaporized it entirely? No answer fit. Every theory contradicted the next. As data accumulated, a subtle shift occurred in the community's tone. Skepticism gave way to quiet respect, then to a sort of reverence. It was as though the comet itself had become a teacher, one that didn't speak, only demonstrated. Each night it moved across the sky, patient and inscrutable, while human minds chased explanations that dissolved under scrutiny. Then came the moment that changed everything, the first detection of non-gravitational acceleration. It was slight, almost imperceptible, but statistically solid. Atlas was moving in a way gravity alone could not explain. In ordinary comets, such motion comes from venting gases, natural thrust created by sublimating ice. But again, Atlas showed no such emissions. Its coma was thin, its tail nearly invisible. Whatever was pushing it forward was invisible too. Some called it a phantom force. Others, less romantic, called it an error in modelling. But as more measurements confirmed the same pattern, the error vanished and the force remained. Once more, Loeb's team ran the math. The acceleration matched perfectly with what you'd expect if a controlled burst had occurred near perihelion, the exact moment the comet passed closest to the Sun. At that point, a small impulse could yield a huge change in velocity, thanks to the Oberth effect. It was as if Atlas had known when to act. When Loeb published his findings, the phrasing was cautious. The observed trajectory deviation may result from directed mass ejection or other non-thermal processes. But everyone reading it understood what that meant: directed, non-thermal. Those words don't belong to rocks. The scientific world reacted in stages. First came skepticism, then silence, then a surge of late-night data reviews, as if each lab hoped to find something ordinary enough to make the discomfort go away. None did. Meanwhile, telescopes recorded faint anomalies in the blue spectrum bursts of light that flared and faded with mechanical regularity. It was subtle, barely above background noise, but persistent. One researcher described it in a private note as a heartbeat in light. That heartbeat continued as Atlas drifted farther from the Sun, its brightness holding steady even as it cooled. No comet behaves that way. Cooling means fading. But Atlas shone as if nothing had changed, its twin jets stretching across millions of kilometers like luminous veins feeding some invisible system. And still, the question that no one wanted to voice lingered. If this is fragmentation, where are the fragments? If this is propulsion, who or what built it? Theories multiplied faster than observations. Some proposed magnetic propulsion, others chemical anomalies, others a dense shell of unknown material channeling heat in ways unseen before. A few whispered about artificial origin, though only in corridors and private messages. Publicly, they called it non-natural symmetry, which sounded safer. Whatever the cause, the comet's defiance of entropy became its defining feature. It did not fade. It did not fall apart. It simply kept moving, steady, beautiful, and profoundly wrong. By early December, the excitement turned to unease. The object's retrograde orbit placed it on a trajectory that crossed the plane of the planets at a narrow angle. So narrow that one calculation estimated the probability of such alignment at less than 1 in 500. To travel against the rotation of the solar system through its densest plane and emerge intact required precision that gravity alone could not provide. Atlas wasn't just moving through space, it was navigating. As it glided past the inner orbits, Earth's telescopes tracked it with obsessive focus. Night after night, the data streamed in, and the more they watched, the more they realized they were not observing an object, they were observing an event. And somewhere, hidden beneath the language of scientific caution, everyone felt the same quiet truth pressing against the edges of comprehension. We were no longer watching a comet obey the sun. We were watching something else, something obeying itself. As the measurements refined, Atlas's path revealed something else, something that unsettled even the veterans. It wasn't just strange, it was reversed. Every planet, every asteroid, every familiar comet travels counterclockwise around the Sun, bound by the same direction of angular momentum that shaped the solar system billions of years ago. But Atlas was going the other way. retrograde. It moved clockwise, cutting straight through the plane of the planets at a steep angle, like a needle piercing a spinning disk. The odds of a large comet taking such a trajectory and still passing this close to Earth were almost zero. Models estimated the probability at 0.2%, a 1 in 500 chance. And yet there it was, gliding through the familiar order of the solar system as if ignoring every gravitational convention. From Earth, the movement looked wrong in a way that words couldn't capture. While the rest of the sky flowed west to east, Atlas drifted against it, slow, deliberate, defiant. Observers described the experience as eerie, like watching the sky rewind. That reversal alone could have made it legendary. But combined with its symmetrical jets and unexplained acceleration, it turned Atlas into an obsession. No one could quite believe that a random interstellar wanderer could line up so perfectly with the Sun, the planets, and Earth's own orbital plane. It was as if the universe itself had drawn a straight line across its own map and placed Atlas on it. The strange thing was how quiet the data looked. Usually chaos leaves fingerprints, trails of debris, irregular orbits, uneven light. Atlas left none. Its path was clean, too clean. And then someone noticed the coincidence that froze the room. The inclination and eccentricity of Atlas's orbit, its steep tilt and open, hyperbolic curve matched another object almost perfectly. An object humanity had met before. Oumuamua. Years earlier, that first interstellar visitor had entered our system just as mysteriously, moving too fast to be bound by the sun's gravity, reflecting sunlight with unnatural precision, accelerating without visible exhaust. The resemblance was undeniable. Both objects followed hyperbolic escape trajectories. Both showed non-gravitational acceleration without dust or gas. Both travelled retrograde. And now Atlas was performing on the same stage, only larger, brighter, and far more deliberate. It was as though the universe had written a sequel. Scientists compared parameters, velocity vectors, orbital elements, inclination. Within statistical error, Atlas and Oumuamua shared the same general direction of origin, somewhere near the Carina-Sagittarius arm, a few thousand light-years away. That region wasn't empty, but it wasn't known for ejecting material in such a way. No stellar nursery, no collapsing system, no violent event to cast debris across interstellar space. The odds that two unrelated objects, both hyperbolic, both accelerating unnaturally, both reflecting light in the same unfiltered spectrum, could appear within a few years of each other, were beyond calculation. And yet, probability doesn't negotiate with evidence. At first, the comparison was cautious. Similarities, shared parameters, possible origin overlap. But it didn't take long before the word pattern appeared in peer discussions. And once that word entered the vocabulary, everything changed. The connection to Oumuamua reignited an old argument. Was it a natural fragment or something else? Back then, Loeb had proposed a radical idea that the first visitor might have been an artifact, perhaps a probe or fragment of technology from another civilization. The claim drew criticism, even ridicule. But Atlas brought that conversation back to life, no longer as speculation, but as necessity. Because now there were two bodies separated by years, behaving with the same physics-defying grace, both too precise to be chance. both silent in all detectable spectra, both leaving behind no debris, no thermal emissions, no sign of decay. One could be an accident. Two suggested intention. For Loeb, this was vindication, though he never said it aloud. He simply urged patience. If nature repeats a mystery, he wrote, it may not be a mystery anymore. It may be a message. The line spread quickly. Journalists quoted it, skeptics mocked it, but astronomers kept returning to the data because the data didn't care what anyone believed. Meanwhile, the jets of Atlas began to fade, not vanish, but stretch thinner, as though the object were shutting down, reducing its activity for reasons no one could predict. The symmetry remained perfect. The light curve stayed steady. It looked less like decay and more like power management. In December, new images showed that the material extending toward the Sun was no longer expanding. It had frozen in place, a still filament millions of kilometers long, unbroken by turbulence. Such stillness shouldn't exist in solar wind. It was like a flag motionless in a storm. Amid the growing unease, the comparisons deepened. Oumuamua had shown reflective bursts, tiny flashes that some interpreted as rotation or tumbling, others as controlled maneuvering. Atlas showed the same pattern, but slower, smoother. If Oumuamua had been a scout, Atlas felt like something designed for endurance larger, steadier, more complex. At night, when most scientists had gone home, a few would remain in the observatories, sitting in the faint hum of machines, watching the data scroll. There was no official word for what they were seeing, but they all felt it. A quiet awareness that perhaps for the first time, they weren't just looking at something, they were being watched back. Still, there was no signal, no transmission, nothing that could be called communication. Just movement, geometry, and silence. It was the silence that unnerved them most. The universe, they realized, doesn't have to shout to be heard. Sometimes it just has to do something that makes no sense and then wait to see if we notice. And humanity had noticed. By now, every telescope capable of tracking Atlas was scheduled to observe it during its closest approach on December 19th. If it was natural, that would be the day the truth would reveal itself. If it wasn't, maybe nothing would. In the weeks leading up to that date, the tension in the scientific world was palpable. Research centers whispered about withheld data, unshared imagery, quiet internal directives not to speculate. There were rumors, unconfirmed but persistent, that NASA's Mars Reconnaissance Orbiter had captured images so detailed they could show structural patterns on Atlas's surface. The data existed, but access was frozen under what officials called procedural delay. For a community built on transparency, that silence spoke louder than any announcement. And so, as the comet, if it was still a comet, drifted closer to its point of nearest approach, humanity found itself watching not just the sky, but its own reflection in it, curious, afraid, and pretending not to be either. By early December, the world's observatories moved into a quiet kind of readiness. Atlas was still weeks away from its closest pass, but every telescope capable of tracking it was already booked. The European Southern Observatory scheduled continuous exposure windows. The James Webb team rearranged its queue. Even the smallest private facilities prepared for the moment. The tone wasn't excitement anymore, it was vigilance. Everyone sensed that whatever Atlas was, this would be the last chance to see it clearly. After December 19th, it would begin to fade, slipping back into the black, where instruments could no longer follow. The silence from NASA grew louder. Requests for data went unanswered. The Mars Reconnaissance Orbiter had captured Atlas as it passed near Mars, an event that would normally produce immediate releases, press conferences, open analysis. This time, nothing. The official reason was bureaucratic, data pipelines frozen by the government shutdown, but few believed that anymore. Behind closed doors, researchers began to compare what little they had. The Chinese Space Agency released its own images, rough but genuine, showing a smooth sphere with a faint outer halo. The European Space Agency followed with 2 frames from Mars Express. Both showed the same thing, a bright compact nucleus with almost no visible tail. The comparison left everyone unsettled. The surface looked too clean, too even. It reflected light like polished stone. When asked, NASA spokespeople repeated the same line: "We will release the calibrated imagery as soon as operations resume." But weeks passed, the silence stretched. The most detailed pictures humanity had ever taken of an interstellar object were sitting on servers, unseen. Then the leaks began. A handful of internal memos reached the community through unofficial channels. Tiny excerpts, but enough to stir chaos. They described radar echoes that didn't match ice or dust, polarization values closer to metal than to rock, even hints of geometric shadowing, as if parts of the surface had sharp edges. The documents were real. The panic was quiet but widespread. For the first time, people outside the scientific community started paying attention. News outlets ran cautious headlines. Politicians asked questions they didn't understand. A congressional letter demanded the immediate release of all data related to 3I Atlas, citing scientific and national significance. NASA responded with a polite statement about protocol and staffing shortages. Loeb, unwilling to stay silent, published a short essay. He called it The Science of Delay. In it, he wrote that withholding data from observation was the modern form of superstition, fear of what evidence might reveal. The paper didn't accuse anyone of conspiracy, but it didn't have to. The implication was clear. Someone, somewhere, had seen something they weren't ready to share. As the days shortened, Atlas drew closer, its light steady, unwavering. Telescopes caught faint oscillations in its brightness. Small, regular pulses repeating every 11 hours, matching the rotation pattern first recorded weeks earlier. The rhythm was perfect, unnatural perfection again. When December 19th arrived, the sky itself felt tense. In northern observatories, the air was clear, dry, the kind of night astronomers dream of. Instruments aligned, timers ticked, and across the world the data started flowing in. For a few hours, humanity watched the stranger at its nearest point, just under 2 astronomical units away, far but close enough for precision. The results came quickly. Spectroscopy returned empty. No water vapor, no carbon compounds, no trace of the volatile gases that define comets. Instead, a flat spectrum light reflecting evenly across all wavelengths, like a mirror. Radar signals returned smoother than any known natural surface. The echo strength was weak but consistent, bouncing off what looked less like porous rock and more like a dense unified shell. Infrared scans showed no heat variations, just uniform temperature across the entire visible face. That should have been impossible. Real comets glow unevenly, warm where sunlight strikes, cold in shadow. Atlas showed no such difference. Its surface behaved like something that redistributed energy instantly, as though wrapped in a conducting layer. By midnight, observatories began exchanging encrypted data packets. It wasn't secrecy born of paranoia, it was defense against noise, against speculation. But the rumors spread anyway. Someone claimed to see rectilinear shadows near the jet origins. Another insisted the object's pulse frequency had changed by fractions of a second. None of it could be confirmed, and yet no one dared to dismiss it. And then, as quickly as it had come, Atlas began to fade. By dawn, its magnitude had dropped below visible thresholds. The data flow slowed. The world exhaled, half relieved, half disappointed. For most people, that was the end. The sky returned to silence and headlines moved on. But for the ones who had been watching, the story was just beginning. Over the following days, as the data was processed and calibrated, patterns emerged. The acceleration didn't stop after perihelion, it changed direction. Instead of continuing outward on a clean hyperbolic escape, Atlas adjusted slightly, as if correcting its path. The shift was tiny fractions of a degree, but precise, purposeful. One senior analyst reviewing the orbital solution wrote in a margin note, "Trajectory resembles course correction, not drift." The phrase was later redacted from the final report. In January, as the object grew too faint for ordinary instruments, the last confirmed radar contact came from the Goldstone Observatory. The echo profile was unlike anything recorded from a comet before. Low polarization, smooth curvature, high reflectivity. The report summarized it in 3 words: surface appears solid. By February, Atlas was gone. No tail, no fragments, no debris trail, just absence. The data archive filled terabytes light curves, spectra, radar images, but none of it answered the simplest question: what was this thing? When the Mars images were finally released months later, the world barely noticed. 12 frames out of hundreds. A faint ellipsoid, 2.5 kilometers long, smooth and featureless. In 3 of them, a bright point appeared beside it, too sharp to be noise, too small to classify. NASA offered no comment. By then, public interest had drifted elsewhere. The only ones still talking about Atlas were those who couldn't let it go. For them, the object had become a mirror. A reminder that our instruments, no matter how advanced, are still designed to see what we expect. When something appears that doesn't fit those expectations, we call it anomaly. But maybe anomaly is just another word for frontier. And so, as Atlas receded into the dark between stars, what remained wasn't fear or wonder, it was humility. The realization that the cosmos doesn't hide its secrets from us out of malice. It simply doesn't care if we're ready. By the time Atlas was officially declared unobservable, the world had already moved on. But for scientists, it never really left. Its data sat on screens, in archives, in sleepless minds that kept circling the same questions. The comet, if it ever was, one had passed, yet it left behind something heavier than dust: doubt. In the months that followed, the debates became ritual. Each camp clung to its explanation like a compass. Some argued that Atlas was natural, a fragment hardened by millennia of radiation, so desiccated that it no longer produced a tail. They said its symmetry, Its rotation, its acceleration, all of it could be the extreme edge of known physics. Possible, though barely. Others disagreed. They pointed to the flat spectra, the perfect heat distribution, the absence of volatiles, the pulse-like light curve. They saw not extremity but intention, something built to endure, something that behaved as if it were conserving energy, not losing it. Papers appeared, cautiously worded, layered with disclaimers. Terms like engineered thermodynamics and non-random surface geometry slipped into print. Every phrase was hedged with probability, yet every paragraph edged closer to the same forbidden idea. Atlas might not be a comet at all. When the final radar data from Goldstone was reviewed, it showed a surface smoother than any known natural body. Polarization suggested metal, not rock. The reflection pattern was oddly uniform, almost as if the object's skin had been polished or designed to scatter energy evenly in all directions. But the most haunting discovery came months later, buried in the light curve archives. A team at the University of Oslo noticed something no one had caught before. The periodic flashes, the heartbeat in the light, had shifted slightly just before Atlas vanished. The frequency increased by less than 1%, then stabilized, as if responding to an external command. That detail never made headlines. It was too subtle, too unverifiable. But for those who studied the data, it felt like an answer disguised as a question. By mid-year, the scientific establishment began closing the conversation. Funding expired, instruments turned toward nearer targets, papers were filed away. Officially, 3I Atlas was classified as a non-periodic interstellar comet of unknown composition. The phrase satisfied protocol but explained nothing. Loeb refused to let it fade. In interviews, he reminded people that the unknown isn't supposed to be comfortable. "We can't build truth out of silence," he said. "If the data scares us, that's all the more reason to look closer." He wasn't alone anymore. Across the world, younger astronomers, people who had grown up watching the mystery unfold, began designing projects that treated interstellar objects not as anomalies, but as a field of study. The term isoscience entered textbooks within a year. Governments took notice. The European Space Agency revived its long-dormant Comet Interceptor mission, rewriting its parameters for hyperbolic targets. NASA's Interstellar Probe concept, once a paper fantasy, gained real funding. Plans emerged for telescopes that could detect incoming interstellar bodies years in advance before they slipped through unnoticed. Atlas had turned doubt into infrastructure. But not everyone looked outward. For some, the lesson was inward. The event forced humanity to confront a harder truth, that we measure the universe with tools built to reflect ourselves. We look for the familiar tails, heat, chaos, and when we don't find it, we call the result impossible. Yet the universe has no obligation to behave in ways that comfort us. Some philosophers wrote that Atlas redefined what evidence means. It wasn't proof of life, or technology, or purpose. It was proof of possibility. The simple, undeniable fact that something can exist outside every law we thought was absolute and still be real. By the second year, the mystery had settled into culture. Artists painted the blue jets like wings of frozen light. Poets wrote about the comet that pushed against the sun. A small documentary called The Visitor Who Forgot to Leave became a quiet success online. its narration built entirely from public domain telescope logs and human silence. And slowly, in that silence, the memory of fear softened into something closer to awe. In a lecture that later went viral, an astrophysicist described it this way: Atlas didn't change science, it changed posture. We stopped assuming the universe is smaller than our imagination. The data still existed, petabytes of it, locked in archives across institutions. Every few months, someone would reopen the files, hoping for new patterns, better software, sharper algorithms. And every time the same numbers returned, stubbornly refusing to say more. Until one night, almost a year after the comet's departure, a team in Chile ran a new analysis on old infrared recordings. What they found wasn't new data, just a pattern they had overlooked, a faint signal echoing through several observations. It wasn't a radio transmission or anything structured, just a repeating drop in infrared brightness that synchronized across different telescopes, half a world apart. The delay between the signals matched the travel time of light. To most, it was a coincidence. To a few, it was something else. If Atlas had been rotating, the pattern could be an artifact of that motion, but the precision of the synchronization down to milliseconds felt uncanny. As though, at some final moment before it faded, the object had aligned itself, reflecting sunlight not randomly, but intentionally. They didn't publish the finding right away. They didn't even call it evidence. It was too small, too subtle. But privately, the lead researcher wrote in her notebook a single sentence that later leaked online. It blinked goodbye. That line travelled faster than any scientific paper. It carried everything: the wonder, the fear, the hope that maybe the silence hadn't been silence at all. By the following spring, Atlas was long beyond the reach of our telescopes, already crossing the orbits of the outer planets, heading back toward the void it came from. The last data point placed it 30 astronomical units away, fading into statistical noise. It had become a legend, but a quiet one. No monuments, no global hysteria, just the soft recognition that once something had passed through our sky and reminded us that we don't have all the words yet. For Loeb, it was enough. We may never know what Atlas was, he wrote in his final report, but perhaps that's not the failure we think it is. To encounter something we can't define is to remember what curiosity feels like. That sentence closed the official record of 3I Atlas. But the story didn't end there. Not really. Because the universe doesn't do endings, it only does departures. And somewhere, far beyond the reach of any signal we can send, a small silent shape continues its journey through the dark, still pulsing with the same steady rhythm, still untouched by time or explanation. Perhaps one day we'll meet another. Perhaps we'll even be ready. But until then, the night sky carries a faint memory, a reminder written not in words but in motion, that once, for a brief and brilliant moment, something came against the current of the sun and kept going. Years later, the story of Atlas began to split into two versions. In one, it was a scientific anomaly, a lesson in humility, proof that even the cleanest data can mislead. In the other, it was something else entirely, a messenger, a sign that intelligence doesn't always speak in language, but in precision. Both versions coexisted because the truth refused to choose. At conferences, you could feel the divide in the room. The older astronomers spoke of outgassing models, radiation pressure, and exotic ice compounds. The younger ones spoke in silences, those long pauses before a question, the kind that mean, what if they're wrong? Over time, a few patterns emerged from the chaos, small but persistent. Objects on trajectories similar to atlases appeared again, faint, fast, and always just barely detectable. None as bright, none as grand, but enough to make people notice. Each one moved with slight irregularities in speed, as though guided by something more deliberate than gravity. They called them mirror bodies, unofficially. The term didn't stick, but the observation did. Governments said little. Publicly, the discoveries were categorized as near interstellar debris. Privately, the funding for deep sky radar systems doubled. The official explanation was planetary defense. But no one missed the irony that we were defending ourselves from rocks we couldn't explain. Amid all that quiet activity, something subtle changed in how humanity looked at the sky. There was less arrogance now, less talk about mastering space, more listening. For some, that shift was spiritual, for others, purely scientific. But the boundary between those two had never been thinner. In university halls, a new generation studied the data not as a riddle to solve, but as a conversation to continue. They didn't look for proof of life, they looked for proof of attention. Because the one thing everyone agreed on was that Atlas had been aware in some way of its own motion. Not conscious, perhaps, but aware, like a machine that knows its balance without ever learning what balance means. Some even suggested that the object's purpose wasn't to communicate at all, but to be seen, that the act of observation itself was the point, as if the universe had placed it here like a mirror, waiting to see how we'd react. And maybe that was the experiment all along, because after Atlas, the question of life elsewhere stopped being about proof and started being about perspective. The cosmos no longer looked empty, it looked full of timing. Every movement, every coincidence, every improbable alignment now felt deliberate, even if only as part of some larger harmony we hadn't yet learned to hear. The effect on culture was quieter, but deeper than any headline. Artists painted the blue light of Atlas not as a comet, but as a wound in the dark. Writers filled shelves with stories of silent visitors, unarmed and indifferent. Musicians composed pieces built on 11-beat rhythms, the same rotation period that had once pulsed through the comet's light. Even religion shifted. In temples, synagogues, mosques, small verses began to appear about the comet of silence, not divine, not alien, simply a reminder that creation still contains things we cannot name. And through all of it, the scientists kept looking. They built new instruments, quieter, more patient, designed not just to see, but to wait. When the first of those instruments came online, it didn't look outward, but inward. It reprocessed all the old Atlas data, searching for echoes, faint gravitational ripples, micro-lensing effects, anything that might suggest mass interacting with space. And on the edge of its analysis, it found something small, almost laughably minor. A dip in the data from the days after Atlas disappeared. The dip wasn't a signal, not in any traditional sense. It was a gravitational shimmer, a momentary warping of starlight in a direction opposite to where Atlas should have gone. A recoil, like the faint twitch of something leaving faster than light could follow. No one published it. No one dared. Because to publish meant to believe it. But for the few who saw those lines, the conclusion came quietly. If Atlas had moved that way, it hadn't just drifted into darkness. It had departed, not by decay, but by choice. And that thought, more than anything else, changed the meaning of the word possible. From that point, the universe stopped feeling like a puzzle to solve and started feeling like a mind to meet. A vast intelligence not speaking through words, but through geometry, patience, and impossible grace. For a time, it seemed the world had forgotten Atlas. News cycles moved on, governments shifted focus, and the night sky returned to being ordinary again. But ordinary had changed. People no longer looked up for reassurance. They looked up to listen. There was a subtle change in the rhythm of human curiosity. It wasn't loud or heroic. It was quieter scientists working late, not because they hoped for fame, but because they couldn't sleep knowing the mystery remained. In old observatories with cracked tiles and hums of aging machines, graduate students whispered about Atlas like a ghost story that somehow felt kind. What haunted them wasn't fear. It was the possibility that the universe had tried to tell them something, and they might have missed it. A generation grew up with that silence. They called it the Atlas Gap, the time between discovery and understanding, between observation and meaning. It wasn't just an astronomical term. It became cultural shorthand for everything humanity saw but couldn't yet explain. The Atlas Gap appeared in literature, in design, in politics. Whenever a question felt too big for an immediate answer, people would shrug and say, "We're still in the gap." In that sense, the comet, if that's what it truly was, had left a fingerprint far larger than its size. Across disciplines, scientists began revisiting old data with new patience. Astrobiologists searched for indirect signatures of control movements too deliberate to be random, energy distributions too neat for chaos. Engineers built simulation models that mimicked Atlas's energy efficiency, not to copy it, but to understand the principle of how something could do so much while showing so little. The phrase apparent effortlessness became its own field of study. It inspired spacecraft design, propulsion theories, even architecture on Earth. Some buildings constructed in those years followed patterns traced from the comet's light curves angles that shifted energy flow in ways the human eye couldn't perceive but somehow felt right. But while culture embraced the mystery, the scientific core refused to let it drift into poetry. A small, persistent group kept pushing for answers. They gathered data from probes, from planetary flybys, from deep space observatories. They mapped every hyperbolic object discovered since 3I Atlas and found more than coincidence. A handful of trajectories scattered over decades aligned along a narrow corridor through the solar plane, as if all of them were crossing the same invisible highway. It wasn't a line of attack or approach, it was a pattern of timing. Each passage occurred roughly in intervals divisible by 11 years. That number again. 11, the period of Atlas's rotation, the rhythm of its light. Coincidence, perhaps? But coincidences start to feel intentional when they repeat too precisely. The project that grew from those findings was small and privately funded at first. A cluster of radio telescopes in the Atacama Desert, retooled to listen for ultra-low frequency signals from the regions where those interstellar travelers had passed. The scientists involved didn't talk about aliens, they talked about resonance. The idea that cosmic motion might leave harmonic traces in the electromagnetic background, like ripples on a pond long after a stone has sunk. Most of the time, the equipment heard nothing but static. But once in a while, the noise aligned. Tiny oscillations too structured to be random. Each alignment lasted no more than a second, spaced by intervals close to 11 minutes apart. They never called it a signal. They called it persistence. By then, the debate wasn't about proof anymore. It was about readiness. What would humanity even do if the proof arrived? The question, once thrilling, had become sobering. Because evidence implies responsibility, and responsibility is heavier than wonder. While that discussion simmered, something else began unfolding. Something quieter, but perhaps more profound. The study of consciousness, long trapped between philosophy and neuroscience, borrowed from the Atlas mystery. Researchers asked whether awareness itself might be a kind of orbit, a feedback loop between observation and change. If a comet could alter its path in response to sunlight, could thought itself be a form of cosmic motion, a curve drawn through the unknown by attention alone? The idea spread slowly, carried by the same people who had grown up under Atlas's blue light. They didn't see the object as alien, but as a metaphor for awareness at scale, a presence so vast it didn't need intention to create beauty. Documentaries from that era showed the shift. In one, an astronomer in her 60s stood under a sky dense with stars and said softly, "Maybe Atlas wasn't built to travel. Maybe it was built to be seen." Her words were broadcast worldwide, not as revelation, but as relief. Because deep down, most people no longer wanted Atlas to be an engine or a ship. They wanted it to be something simpler proof that the universe still surprises us without needing to explain itself. But surprises have gravity. In 2031, 8 years after the event, the James Webb Telescope captured an unexpected flare in a distant sector of interstellar space. It wasn't large, but its wavelength was peculiar. A concentrated burst of blue light lasting 11 seconds, originating from a region aligned with Atlas's last projected trajectory. The observation was logged, analyzed, and archived. Officially, it was a gamma anomaly, an energetic outburst from an unseen star. Unofficially, the note in the internal report said, "Atlas Echo possible." No one claimed it publicly. No one had to. The idea was already moving on its own. Soon, new projects emerged with names that echoed the old legend. Project Horizon 11, the Blue Path Initiative, Resonant Silence. None claimed to chase Atlas directly, but all drew their inspiration from the same quiet defiance, the refusal to assume we've seen everything worth seeing. And still, the public fascination endured. Children who had once watched their parents stare through telescopes now worked on those very instruments. Their textbooks didn't frame Atlas as anomaly. It was a milestone, the first recorded moment when humanity realized it might not be the most patient intelligence in the room. In the years that followed, more interstellar objects were catalogued. None behaved quite like Atlas, but traces of its pattern lingered, the smoothness of trajectory, the clean reflectivity, the faint rhythm in the light. Astronomers stopped dismissing these as coincidences. They began calling them signatures of intent, a neutral term that didn't require belief, only observation. And yet, the closer humanity came to understanding, the less certain it felt. Because knowledge doesn't always comfort, sometimes it humbles. A philosopher once said that science isn't the opposite of faith, it's faith that's learned to measure. Atlas proved that even the measurable can remain sacred. When historians look back, they'll say Atlas marked the end of a kind of innocence. Not because it revealed aliens or technology, but because it reminded us that discovery isn't a straight path from ignorance to knowledge. It's a circle, and sometimes we return to the same mystery with wiser eyes. In that sense, Atlas never really left. It simply shifted phase from an object to an idea, from a question to a mirror. By the second decade after its passing, most of the early data had been reprocessed with new quantum algorithms. The results didn't change the story, they deepened it. Faint patterns in the jets showed interference waves, overlapping frequencies too orderly to be chaos. Mathematicians converted them into sound for analysis. What they heard wasn't language, but rhythm slow, balanced, almost musical. When those recordings were released, they filled planetariums and art exhibits. People sat in darkness, listening to the sound of motion recorded years earlier. It wasn't alien, it was human. It sounded like breathing. Some said it was coincidence, some said it was proof, but most said nothing. They just listened. In that moment, you could almost imagine that Atlas hadn't left at all, that somewhere beyond the reach of any telescope, it was still moving, still singing softly through the void, leaving trails of invisible resonance that one day, perhaps, someone else might follow. Maybe that's how communication works at the scale of eternity, not through words or signals, but through the shaping of paths. And so the story remained unfinished, as every true story of the cosmos must, because endings are only the limits of perception, not of reality. Long after the last telemetry faded, Atlas kept a quiet place in the minds of those who had watched it. Years passed, and yet the conversation never fully ended. Every few months a new paper appeared, smaller than the last, citing fragments of data, trying to fold the impossible back into known equations. None of them succeeded. What lingered wasn't evidence but presence, the feeling of something vast moving just beyond comprehension. Even those who never believed the wilder theories admitted that the object had changed the texture of astronomy. It had reminded people that not all mystery is ignorance. Some mystery is design. Observatories began to adopt a habit born from Atlas. Whenever a telescope caught a faint, fast-moving body on a strange path, operators paused before labeling it. They checked twice, 3 times. They called it an Atlas check, half joking, half serious, a superstition disguised as procedure. In time, the data archives turned into legends of their own. Students exploring them decades later found the raw telemetry, strings of numbers that once made grown scientists doubt everything they knew. They didn't see fear in those numbers. They saw wonder. And perhaps that was the quiet gift the visitor had left behind. No one knows where Atlas is now. The simulations place it somewhere beyond the heliopause, drifting between the stars, farther each second from the warmth that first revealed it. The jets are long gone, the light dispersed, the silence complete. But silence isn't absence, it's continuation in another form. Sometimes late at night, astronomers still point their instruments toward the coordinates where it should be, knowing the signal will return nothing but background noise. They do it anyway, not for data, but for the feeling that somewhere out there, something remembers. And maybe that's what Atlas was meant to teach, that discovery is not about possession, but attention. That the universe doesn't wait for our readiness. It only offers moments. Some we measure, some we live. It's easy to think of the event as over, sealed in reports and archived footage. But the truth is gentler. Atlas is still happening. Every question it raised still ripples through new ideas, new missions, new eyes looking up. Every time a scientist hesitates before saying impossible, the comet passes again, invisible but present, a thin line of light across the inner sky of thought. In the end, there was no revelation, no message carved into light, no sound to decode. There was only motion, perfect, silent, and deliberate, reminding us that the unknown is not our enemy. It's the shape of everything we have yet to learn. And as Earth spins on, wrapped in its narrow orbit of certainty, somewhere in the dark, a faint blue glimmer travels outward, never slowing, never speaking, never fading.